Hello, all. Good evening, and welcome for the next session. Diophantine Equations. We were doing this the last time as well. So there is a lot of scope of different kind of problems in this, and therefore we'll continue with this and look at um the further kind of varieties of the questions on this. Let me again remind what was the agenda. Diophantine equations. So all the questions again on algebra, but the ones which involve us to solve questions where the variables that are involved, they need to be integers, right? So that involves a whole lot of different logics and style in which the questions are handled, right? So we already seen some of them last time, and let's continue further on this style of problems. The questions themselves can deal with either linear or quadratic or other equations of higher degree as well. All right, so let's start. All right, so here it is, the first question. Shirish goes to buy certain pens, pencils, and erasers which cost 5 rupees, 4 rupees, and zero point 0.5 rupees a piece. He ends up buying a total of 50 items worth rupees 50. What proportion of the total amount was spent in buying the erasers? So clearly the question involves three things: uh, pens, pencils, erasers, and the information that we have is only two, in the sense that number of items bought and amount spent. So we can only create two equations in three variables, right? So this is a kind of a problem we have seen many times. Three variables are involved, but only two equations we can write. Right now, this time, however, an exact answer is expected. So there must be something hidden here. So let's explore. Right. So if I denote, let's say, the number of pens, pencils, and erasers bought respectively as, let's say, X, Y, and Z, number of items bought. So that is 20. That is 50 in total. So our first equation becomes that X plus Y plus Z equals 50, right? That's my first information. Second, again, amount on the amount spent, which is 50 rupees in total. So with respect to the price given to us, 4 and half a rupee, so we can write that 5x is the amount spent on pens, on pencils 4y, and half a rupee on erasers, so half of Z. So that equals again 50. I don't like seeing a fractional coefficient. So what I'll do is I'll multiply the second equation with 2, and then I'll write it as 10x, 8y, and z. So that much is 100, right? So two equations that we were talking about. Now we want to find the amount spent on erasers is what proportion the total amount. We know that the total amount spent is 50 rupees. So the amount spent on erasers would be this z by 2. So we have to basically find the value of this z by 2, the amount spent on erasers over 50 rupees. So we have to find z basically. Now we can see that z can be easily eliminated between the two equations, and we can get one equation in terms of x and y. Let's do that and let's see what happens. So 10x, so I'm subtracting first from second equation minus first equation. So 10 minus 1, 9x, and then 8 minus 1, which is 7y, and z cancels off. So that is 100 minus 50, or 50, right? 9x plus 7y is 50. Obviously x and y are integers, right? So that's the integer constraint, and so therefore we are looking for integers x and y which satisfy this equation. So a multiple of 9 and a multiple of 7 adds up to 50. So let's think of the possibilities. If I start putting the values of x as 1, 2, 3, let's see what we get. If I put this as 1, then 9 plus this will be left as 41. 41 is not a multiple of 7. If I put this as 18, 9 into 2, 18, then 50 minus 18, uh, uh, what, 38, right? Sorry, 28. That is not a multiple. Sorry. If I put this as x as 2, so 18, 50 minus 18, 32. So 32 is not a multiple of 7, right? If I put x as 3, so 9 into 3, 27. And what is left? 23. Again, 7 is not, that is 23 is not a multiple of 7. If I put x as 4, 9 into 4, 36. Then I'm left with 50 minus 36, 14. 14 works, right? So x equal to 1 does not work. 9 plus 41, x equal to 2 does not work. X equal to 3 does not work. X equal to 4 works. And this is the only possibility. Obviously, this is the only one, because if I put x as 5, then 9 5s are 45, then only 5 rupees is left, which is not a multiple of 7, and we cannot go further. So therefore, we have a unique solution given that this equation needs to be satisfied. 9x plus 7y is 50. So that means x must be what? We have put x as 4 over here. 9 into 4, 36. And 7 into 2, 14. So we have put the value of y as 2. X is 4, y is 2. And x plus y plus z is 50. So therefore, z is obviously 50 minus 4 minus 2. So 50 minus 6, 44. So this is the fraction that we are trying to find. Z has come to be 44. So 44 by 2, 22 rupees is spent on erasers out of 50. So 22 by 50 is 44%. And that's the answer. Right? So that's how this got solved, because the linear equation that we got under the condition, under the constraint that the variables are integers, had a unique solution. All right. So this kind of logic can come up and is quite relevant. Let's see next one. Question 2. Rahim, a potter, makes more than 100 but less than 200 pots and arranges them in rows, each row having the same number of pots to dry. If he had placed 6 more pots per row, he could arrange the pots in 10 less rows. If Rahim had instead placed 1 less pot per row, how many more rows are required to arrange the pots? Very nice. First of all, understand that in this kind of arrangement where we are putting the things in rows and columns, just for illustration, I'm just drawing over here, let's say a small matrix. Let's say this is a grid in which I have put 3 rows and 4 columns. 3 rows, 4 columns. Let's say this was the arrangement. Let's just say, right? So there would be 3 rows and 4 pots in each row. Can I say that 4 is the number of columns? So this thing that the question keeps on talking about, the number of pots in each row, is basically the number of columns, right? Let me denote that R and C denote the number of rows and columns, such that R into C is the total number of pots n. Let's say n equal to R into C, where R is the number of rows, C is the number of columns. C is also the number of pots in each row, right? So my n is R into C. If he had placed 6 more pots per row, means the number of columns was 6 more, which means C was C plus 6 instead of C. He could arrange the pots in 10 less rows, so the number of rows becomes R minus 10. So the same number of pots could be arranged in n R minus 10 rows and C plus 6 columns. So the number of pots are the same. So therefore we can equate R into C as also R plus 10 into C minus 6. Sorry, my bad. I think I have written it the other way around. This is R minus 10, 10 less rows and 6 more columns, C plus 6, right? So therefore something will surely come from this equation. R into C is this. So let's expand this, right? So we get R into C, this, and plus 6 into R, and minus 10 into C, and minus 60. So in this equation, R into C cancels on both the sides, and we get a linear equation which says that 6R minus 10C minus 60 is 0, or 6R minus 10C is 60. 2 can be cancelled off, and we can write that 3R minus 5C equals 30. Now remember, there was this constraint given to us that the number of pots, which is n, which is r into c, that value is more than 100 but less than 200, right? So this constraint has to be satisfied. So we are looking obviously for integer solutions of this linear equation once again, right? Such that the values of r and c are such that their product is in this range over here. So let's find the combinations of r and c from this linear equation, and hence the value of n, which is r into c. If I put c as 0, just mathematically speaking, just for the first solution, I'm not saying that c can be 0, but I'm just saying mathematically speaking, this linear equation has the solution. Can I say 10 comma 0? For c equal to 0, r is 10, right? So although that's not a, obviously that's not a valid solution to under the given circumstance for the context of the question, but just saying this linear equation, I can start with this solution. And as we discussed last time, that once we find this initial solution, the further solutions are obtained by changing the values of each of the variables in terms of the other variable coefficient, right? Which means that r is 10, so it will keep on increasing by 5, the coefficient of c, and c is 0, it will keep on changing by 3, the coefficient of r. So it's a difference equation, not a sum equation. So can I say if r is increasing, c will also increase to maintain the constant difference, right? This time they will not change in the opposite direction. They will both change in the same direction. Both will increase. So if I'm increasing r by 5, which is 15, then c must also increase by 3, which is 3. Now 15 into 3, 45 is obviously not falling in the range. So we have to search for the next solution. Then 15, if I increase further, then 15 becomes 20, 3 becomes 6, and 20 into 6 is 120. Yes, that is in our desired range, and thus this must be the unique solution. You can check if we go for the next possibility, then 20 is 25, 6 is 9, 25 into 9 is 225, which is outside of the range, right? So therefore this is what we have. Now the question is asking what we have to then we have to figure out that if Rahim had instead placed one less pot per row, how many rows are required to arrange the pots? Which means the number of columns is decreasing by one. Then what happens? Now you see we have this values of r and c, right? 20 and 6. So our n is 20 into 6. This is our value of r. This is our value of c. So question is now asking if Rahim had basically decreased the number of columns by one, right? One less pot per row. So number of columns goes down by one. Right now, the number of columns is 6, right? So if 6 becomes 6 minus 1, 5, then what will happen? The number of pots are still 120. 120 by 5, 24. So the number of rows will become 24. So how many more rows are required to arrange the pots? The number of rows have gone from 20 to 24. So that's an increase of 4, right? So 4 more rows are required, right? So therefore, always, whenever you are given a problem, never feel that the data is going to be insufficient. Some integer constraint might be the logic due to which we might get a unique solution, right? If I want to make this question difficult, I could also put the option of cannot be determined, right? But there is a unique answer, and that is because this linear equation, this one, 3r minus 5c equals 30, under this constraint that r into c has to lie in this range, has a unique solution. All right, ready for the next one? Let's see. Third one. In a colony, there are 65 boys and girls with more boys than girls. 1/5 of the boys and 3/5 of the girls join a cricket camp. The remaining children join a tennis camp. If each child joins only one of the two camps, how many children join the tennis camp? Now, typically we start such question by defining the number of boys and girls as x and y, and we can start writing the equation x plus y is 65. Also, boys are more than girls, so x is more than y. But you see, always quickly scan the question, right? In this problem, it is important to understand from the second statement, there is a very important interpretation. Since I'm doing 1/5 of the boys, I'm doing, I'm taking 1/5 of the boys into the cricket camp. Is it possible that the number of boys are, let's say, 12? Is that possible? Or let's say 16? Or let's say 21? Okay. Sorry, boys are more than girls. Let's say boys are 44. Let's say boys are 37. I hope you're understanding what I'm saying. You cannot have the boys whose 1/5 is not an integer. So that's the inherent, uh, interpretation that you have to seek from the statement. You're taking 1/5 of the boys. It definitely implies that your boys needs to be a multiple of 5 so that you can take 1/5 of them. So instead of taking boys as x, you should take your boys in the initial as the variable as not x but 5x. Only then you can take 1/5 of that. And likewise, your girls, you're doing 3/4 of them. Again, so therefore, you cannot have the girls, let's say, as 25. Okay, you cannot take 3/4 of 25. That would go into a fraction, right? So since you're doing 3/4, so the number of girls needs to be the multiple of 4. So whatever is coming in the denominator, your total quantity has to be multiple of that, so that you are not dealing, your value eventually comes out to be an integer, right? So therefore, likewise, we can say that the girls needs to be a multiple of 4, so we can take them as 4y. And therefore, now we start and solve the question, right? So this logic, right, is something that has to be clearly identified and applied in terms of how we define the variables. Now we can start that, okay, 5x plus 4y is 65, and also at the same time we should have this constraint that 5x is more than 4y, right? The number of boys is more than the number of girls. Okay, so again we are left with just one equation, two variables, right? um, so therefore we are obviously looking for a unique answer. Options tell us there is no option cannot be determined, right? So therefore there must be a unique solution to this linear equation under all the conditions, right? So what values satisfy? Again, for just a starting solution, just for ease of identification of the first initial solution, I'm taking y as 0, because it is easy to then say that, okay, x is 13, 5x is 65, x is 13. Obviously this is not the answer because girls are not 0, but from here we know that we can further find the uh, possible solutions. So now this is a sum equation. Both the variables will change in the opposite direction. I'll obviously decrease x and increase y, and x will decrease in terms of multiples of 4. So 13 minus 4, 9, and y will increase by 5 in terms of 5, the coefficient of x. So 0, so next 5, right? So 5 into 9, 45. 5 into 9, 45, plus 4 into 5, 20 is 65. 45 plus 4 into 5, this, right? 4 into 5, 5 into 9, this adds up to 65. 45 is obviously more than 20. If we go for the next possibility, then x will then decrease by 4. It will become 9 minus 4, 5. Y will increase by 5. It will become 10. And I think this won't work. You can understand. 25 boys, 40 girls won't work. So this is our, again, the unique solution. So there must be 45 boys and 20 girls. So how many went to the tennis camp? How many went to the tennis camp, right? If I took 1/5 of the boys in the cricket camp, it is clearly mentioned that each child joins only one of the two camps, right? So whoever is joining cricket has gone there. All the remaining children will go to the tennis camp. So 1/5 for cricket. So the remaining 4/5 will go for the tennis. So 4/5 of 45, which is 36 from here. and 3/4 of the girls cricket. So remaining 1/4. So 1/4 of 20, which is 5. So 36 boys and 5 girls, which is a total of 41 students, have joined the tennis camp. All right, perfect. Now let's see some of the previous year questions that have come, taking a ZAT problem from 2023. Very interesting question. Like, let's see how we can do this. There is also an option of cannot be determined, right? Mostly that's a trap option, right? But sometimes not. So just be very careful about that. A king has distributed all his rare jewels in 3 boxes. Perfect. The first box contains 1/3 of the rare jewels. Second box contains k by 5 of the rare jewels. So now a variable, the question itself has introduced a variable k, and that variable is a fraction. K fifth of the rare jewels are in the second box for some positive integer value of k. The third box contains 66 rare jewels. How many rare jewels does the king have? Perfect. So, taking a clue from the last problem where the number of boys and girls, we are taking fraction of that. So we took the total value itself as a multiple of the denominators. Whatever factors we were seeing in the denominators, the total needs to be a multiple of that, right? So likewise, we are doing 1/3. We are doing k by 5. So we are in the denominators. I see 3 and 5. So my number of jewels needs to be a multiple of 3 as well as 5 to begin with, because I cannot have jewels again in fractions, decimals, right? I cannot have 7.5 rare jewels. I must have that in integer. So, uh, so therefore, can I say that total number of jewels I can define as a multiple of both 3 and 5, which means a multiple of 15. So let's say they are 15x in number, right? So there is first box, second box, third box, right? So we can define. We already know that there's a exactly 66 jewels in the third box. That value is already known. Now, in terms of fractions, if the first box has 1/3, so that is always having basically 15x by 3, which is 5x number of jewels, right? Now let's consider the different possible values of k. If k is 1, then 1/5 of 15, which is 3x jewels, will be there in the second box. And if that is the case, then 5 plus 3, 8x is here. So the remaining 15x minus 8x, which is 7x, should be here. If I equate 7x to 66, I don't get an integer value of x. And hence, this is not a possible value, right? My x needs to be an integer, right? Because that's defining the number of jewels. So in this way, we can keep on considering the different possible values of k, which is involved in the second fraction, and then we can keep on figuring out that whether or not it satisfies the number of jewels in the third box. So therefore, let's try with the next possibility, k is 2. If that is the case, then 2/5 fraction is there. 2/5 of 15 is 6x. If I put this 6x here, then 5 and 6, 11x have been considered in the first two boxes. So 15 minus 11, which means 4x remains over here in the third box. Again, if I equate that to 66, then x is 66 by 4 or 33 by 2 or 16.5. Again, ruled out. K equal to 3. I have to keep on searching for the valid value, right? K equal to 3. So then 3/5 of 15, which is 9x number of jewels, are in the second box. And then 9 and 5, 14x are here. So only 1x is remaining. 14x is gone from 15x. So x equals 66. Obviously, that's valid solution. And that's the only solution. K equal to 1 and k equal to 2 don't give us a valid solution. K equal to 3 gives. K equal to 4 will again be impossible, because 1/3 plus 4/5 goes more than 1, right? Means you will cross the limit of 100%. So therefore I think this is the answer. X must be 66 is the only solution, right? Because the entire question was resting on this integer constraint on k. So we just had to plug in the different integer values of k and search for the valid solution such that the 66 residuals I can justify to be there in the third box, which is the remaining value. Perfect. So our answer is nothing but the total number of residuals, which is 15x. We have obtained x as 66. So our total number of residuals are 15x. So 15 into 66, which is 990. Right. So that's my answer. So very interesting. And this is how things have been asked. Budvesh is saying, can we take an option to start with? Like option C, 240. Yes, we can also try to backtrack from the options. That is also a way to go, right? But I think I mean, both ways can be done. What I figured out was k equal to 1, 2, 3, right? You can just plug in it because you see your fractions will not have too many options. Like you because one third is already gone, so you cannot put more than two third of the fractions of the residuals in the second box, isn't it? So 1/5, 2/5, 3/5. 3/5 is already 66%. You cannot cross 66%. So only three possibilities were there, right? In my opinion, checking and backtracking from the options might take more time. See, in this question, if you pick the first option and put it over there, so it works. But if I had put the correct option 990 in the D option, and let's say you're trying first, second, third, so then you might get into trouble justifying each option. Then they keep on failing. So I find that sometimes it's a kind of a luck by chance. Okay, does the first option work? No. Second option? No. So in that sense, uh, better to just plug in the values and just see the validity of the answer. That's my take on that. Right, Udvesh? Thank you for your opinion. Sometimes it works, but always what works is just putting in the numbers. All right. Thank you. Let's see the next one. Cat 26, Cat 22 question. In an examination, the average marks of students in sections A and B are 32 and 60 respectively. Wonderful. Average marks is given 32 and 60. The number of students in section A is 10 less than that in section B. Okay. If the average marks of all the students across both the sections combined is an integer, then the difference between the maximum and minimum possible number of students in section A is what? Very interesting problem. First thing, average marks is given. Second thing, number of students, a difference is given. Third thing, average marks is an integer. You see, average marks of two sections combined need not be an integer. It necessarily does not, by its own inherent nature, the average marks right need not be an integer. It is the overall weighted mean basically that you're taking, right? So total marks of all the students taken in the both the sections combined divided by the total number of students, right? That can very well be fraction, right? If let's say students have scored a total of let's say 2000 marks taken across 44 students, so 2000 by 44 is the average marks. But the question is e- e- explicitly putting the integer constraint on that. So how do we deal with this? Let's see, right? Okay, so obviously it's a weighted mean that we are talking of, right? So in section A and B, let me define the number of students and in as a variable based on the difference given that section A has 10 less students. So if I take n students in section A, then section B has 10 more, right? Which is n plus 10, right? You can also take B as n and A as n minus 10. Any which way it is fine. The average marks respectively is 32 and 60. So what is your overall average marks in both the sections combined? can we say 32 into n, right? Total marks will be average into number of students, right? So 32 into n total marks of section A, and n plus 10 into 60, which will be 60n plus 600, right? 60 into n plus 10 whole upon total number of students, which is n plus n plus 10. So 2n plus 10. This expression has been the constraint on this expression is that it is an integer, right? So we must satisfy that constraint. So let's first of all simplify this expression a bit. uh, let me call this as just I'm calling, let's say, m, right? Just I'm defining it as a variable m. This m is an integer, so this m is 32 and 60, 92n plus 600 over 2n plus 10, right? And now I can cancel a factor of 2. So let me further simplify, which is 46n plus 300 over n plus 5. So what I wanted to do was, with this expression, I see linear upon linear. Let me take off, means let me factor off the integer part from this, which means I see n plus 5 in the denominator, I see 46n in the numerator. So can I say 46 can be factored out, means separated from here, such that let me write the numerator as 46 into the denominator itself, which is n plus 5. So this becomes 46n plus 230, and this is 300, right? So what is remaining? 300 minus 230, which is 70 is remaining over n plus 5. So therefore, the integer part, which is 46, can be taken off, and I'm left with 46 plus 70 over n plus 5. So therefore, now I can easily, my mind can easily work on this fraction over here, which actually is not a fraction. It also needs to be an integer. So integer part has been separated, 46. Now 70 over n plus 5, this has the constraint that it needs to be an integer. So therefore, very easily we can therefore say n plus 5 is what? Basically, it should be a divisor of 70, right? So therefore, we are basically, you see what the question is asking, difference between the maximum and minimum possible number of students. So the question itself is saying that this number of students are not unique, they will have multiple possibilities, and those possibilities, now when we mathematically write the equation for the average marks, we are able to interpret that in order for this to be an integer, n plus 5 should be a factor of 70, and also n plus 5, n is a natural number for sure. So n plus 5 is more than of 5, right? So you cannot say, okay, 1 is a factor of 70, so n plus 5 equal to 1. No, that won't work. The factors of 70 which are more than 5 would work, right? So the minimum I can go for is what? 5, 6 is not a factor of 70, 7 is there. 7 could work, no issue with that. Now you might say, oh, n plus 5 is 7, n is 2, a class of 2 students. Now that might be a bit odd to say, but mathematically speaking, we won't say that, okay, that's not a possibility. We'll take that as a possibility, a class of 2 students, right? So n plus 5 equal to 7. 7 is the minimum possibility for n plus 5. So n takes the minimum value of 2. That's the minimum. And as far as the largest possible factor is concerned of 70, it is 70 itself. Very well, why can't we have 70? N plus 5 equal to 70. 70 upon 71. Average marks would be 46 plus 1, 47. So the highest possibility could be 7t for n plus 5, right? So therefore, n maximum could be 70 minus 5, 65. N minimum, as we said, could be 7 minus 5, 2. 65 minus 2. He's asking for the difference of the maximum and minimum possible number. 65 minus 2, 63 is your answer. Okay, CAT 22. So externally means a quantity has been defined to be an integer which need not be, and then we are applying the integer constraint on that, right? So I hope this is interesting, and you're making note of how the things are being, how the integer constraint is being applied and asked in different ways, right? Okay, we'll take few more. previous year questions. Let's see the next one. Another question from cat 2020. Let's see. Okay, let's jump in. Arun bought some pencils and sharpeners. Very nice. Spending same amount of money as Arun, Aditya bought twice as many pencils and 10 less sharpeners. Arun, Aditya, pencils, sharpeners. Some information is there. Uh, Amount of money, spending same amount of money. Aditya bought twice as many pencils and 10 less sharpeners. Number of items bought, some conditions are there. If the cost of one sharpener is 2 rupee more than the cost of a pencil. So now something about cost, price. Then the minimum possible number of pencils bought by Arun and Aditya together is how much? Again, at the end, the question asks for a possibility, not an exact value. So we are not expecting to solve the whole thing with a unique answer, but we have to just frame the problem, which means whatever parameters are there, write the necessary equations, and then figure out how we can minimize the number of pencils bought. The price is involved. What are the parameters? The price of pencils and sharpeners, the number of each of them bought by the two persons, and hence correspondingly the amount spent. So we need to write the expression for that, and at the end write the equation for the fact that they have spent the total same amount of money, right? So let's define the parameters involved. Mostly what I find convenient is making a small table for things, right? uh, Write the things concisely in a tabular form and just process that. So there is Arun and Aditya, and they are trying to buy some pencils for themselves and some sharpeners. So uh, Aditya bought twice as many pencils and 10 less sharpeners. So if X number of pencils were bought by Arun, then Aditya bought 2x number of pencils, twice as many pencils, and 10 less sharpeners. Okay, so if I take this as y for Arun, I would need to take for Aditya y minus 10. I would want to take it the other way around. I don't like writing the negative coefficients. Let me write y sharpness bought by Aditya, then y plus 10 sharpness bought by Arun. Okay, then the cost is involved. So cost of one sharpener is given to be 2 rupee more than the cost of a pencil. Let me take the cost price of a pencil as p rupees, so that sharpener costs p plus 2 rupees, right? So three variables I have taken: x, y, p. I have to take. This is the minimum number of variables I need to take, and I will now only have one equation in these three variables, right? That's so that might be thing that might be intriguing you, that from only one equation in three variables, how do we get this thing? So the question is asking for the minimum possibility, remember, right? We are not expecting to solve x, y, and p uniquely. Okay, let's see what happens. So total amount spent by Arun is what? Amount of spent on pencils. So I'm writing the equation that Arun's amount equals Aditya's amount, right? So Arun on pencils has spent how much amount? P into x, right? Let's see what happens. P into x, and this sharpness p plus 2 into y plus 10, right? We'll expand this. And Aditya has spent on pencils p into 2x, so 2px, and on sharpness p plus 2 into y. Let's expand and see what we can simplify. P into x plus p into y plus p into 10, so 10p, 2 into y, and plus 20 is 2px plus p into y plus 2 into y. Looks very lengthy, but you see some things go off. P into y goes off, 2 into y also cancels, so simplification is happening. What is left? This p into x and this 2px. So this p into x will cancel, and I'll have px on the left, on the right hand side. What I'm left with? So this p into x over here equals this side 10p plus 20. Nice, nice, nice. So y has gone off, right? The variable y is cancelled. I mean, it has been removed, and I'm getting p into x is 10p plus 20. And what is the objective of the question? Minimum number of pencils bought, x plus 2x, which is 3x. This is the total number of pencils bought, which must be minimized. So we are trying to figure out basically the minimum possible value of x. With this equation, p into x is 10p plus 20. Well, okay, so let's just write, let's do one thing, divide by p, so that I can write x is equal to something. X is a function of p, right? What do I get? X equals, so I'm dividing by p, x equals what? 10, right? Dividing by p plus 20 by p. What does this tell me? What is x? X is the number of pencils bought. X is the number of pencils bought. What is p? P is the price. Price need not be an integer. Remember, price can be anything. It can be, I can have a pencil for 4.5 rupees. No issue with that, right? But x is an integer. If x is an integer, which is 10 plus something, and this quantity 20 by p has to be an integer. This 20 by p must be an integer so that x is an integer. What is the minimum value I can assign to 20 by p? It cannot be negative. It cannot be 0 also. Because 20 by p can't be 0. P cannot be infinite. But for the minimum value, the minimum possible positive integer value of 20 by p is 1. Right? So by choosing the value of p such that 20 by p is 1, which means by choosing p as 20, can I say the minimum possible value of x is nothing but 10 plus 1, 11. Isn't it? So this mathematical equation is dictating me that the minimum value of x can only be 11. It cannot be less than 11. But 11 is possible when we choose p as 20. And hence my answer is 3 into 11, 33. Right. So you see, the question did not specify anything as such, but when we wrote the equation mathematically, at the end, the integer constraint came up. So algebra also speaks to us in so many different ways, right? By creating equation, and at the end, we have to apply the integer constraint logic. That's what I'm trying to show, right? So sometimes it is explicitly stated, like in the last question, average is an integer. Here, you figure it out once you frame the equation mathematically. All right. So I hope this is, you're deriving the fruit from this, right? This is how things have been asked. Okay, let's look at the last problem for the session. Let's go for this ZAT 23 problem. Okay, let's do this one as well. Aman has come to the market with 100 rupees. If he buys 5 kg cabbage, 5 kg potato, he will have 20 rupees left. Okay, cabbage, potato, 20 rupees left, 100 rupees to start with, means he spent 80. Or else, if he buys 4 kg cabbage, 5 kg onion. First he talked of cabbage and potato, now he's talking of cabbage and onion. So there are not two things but three things involved: cabbage, potato, onion. He will have 7 rupees left. I can clearly sense it's a question of three equations, three variables, two equations, right? Clearly you can see that from the first two lines, right? So we can create some equations around this. Now, you see the question very explicitly mentions the integer constraint after this. The per kilogram prices of cabbage, onion and potato are positive integers in rupees. So he clearly mentions that integer constraint. And any type of these vegetables can only be purchased in positive integer kilogram or none at all. Very interesting. So I cannot buy half a kg of cabbage or 1.5 kg of potato. So both the price in rupees per kg, as well as the quantity bought in kg are integers. Okay, very nice. Aman decides to buy only onion in whatever maximum quantity possible in positive integer kilogram with the money he has. He has come with 100 rupees. He decides to buy only onion, whatever maximum he can buy, only onion. How much money will he be left with after the purchase? Okay, so let's jump in. Let's create the three variables and write the two equations, and let's see what we can manage. Options tell us we must get a unique answer. It means that obviously I'd need to decode the prices of the three items respectively, and I should be able to decode that uniquely. Let's do that, right? So I'm taking X, Y, Z for the respective prices of cabbage. Cabbage is X, and potato is Y. Potato is Y, and onion is Z. So we are obviously, our focus in on is to decode this value of Z. But I think by virtue of doing so, we'll in any way have to decode all the three prices respectively. Let's see. So first he has spent 80 rupees on this, right? So 5x plus 4y is what he has spent, 80 rupees, right? 100 minus 20, and 7 rupees left. So 100 minus 7, 93 rupees has been spent on 4 kg of cabbage, so 4x, and now therefore 5 kg of onion, so 5z, right? 5x plus 4y is 80, 4x plus 5z is 93. We are trying to figure out the values of x, y, z from here. How will we manage two equations, three variables? Not in that sense that each of the two equations have made use of all the three variables. How do we manage this? Well, isn't it the case that we know how to find integer solution of a linear equation in two variables? We very well know that. So with 5x plus 4y equal to 80, we'll keep on writing the solutions of x and y. And whenever we define that x and y values correspondingly by using the second equation, we'll obviously be able to decode the value of z, which will satisfy the second equation, which needs to be an integer, right? So let's jump in. Again, for the initial solution on x and y, let me start off with x as, so I'm taking y as 0 just for the initial solution. Obviously, it's not 0, but for the initial solution, 5 into 16 is 80. So 16, 0. Just mathematically speaking, 16, 0. Now we know x will keep on decreasing by 4, the coefficient of y, and y will keep on increasing by 5, the coefficient of x, right? So x will keep on decreasing by 4. So 16 minus 4. For the next possibility, this is 12. And 0 plus 5, this is 5. 12 and 5 satisfy. 12 is 60 plus 4 into 5, 20. 60 plus 20 is 80. If x is 12, then coming to the second equation, what do we get for z? 5z is 93 minus 4 into 12, 48. Right, 93 minus 48 is 45. I'm happy to see that. I'm happy to see that 5z is 45. So I'm getting a valid solution. Z is 9. And the problem tells me, the options tell me that this must be the unique answer and the only solution. The only integer solution that satisfy both these linear equations, first and second equation, they must be the only solution, right? You can check. I mean, we in exam we don't need to, but just for your clarity, if you keep on putting any other values of x, you will not get a corresponding integer value of z, right? You know that you can decrease x by another 4, so 12 minus 4, 8, and y will increase by 5, so 10. But then if this is 8, then from 90, if over here you subtract from 93 this value of 4 into x, which is 4 into 8, 32. So 93 minus 32 is 61, is not a multiple of 5, because that's what we need. So therefore further solutions will not suffice. And with this, what do? We are trying to buy only onion using 100 rupees, and we have got z as 9 rupees. So if I'm trying to buy as much of onion and onion costs 9 rupees, then what can I buy? 9 into 11, 99 rupees. I can spend all my 99 rupees maximum on onion. So the question is asking how much money will be he left with after the purchase? 1 rupee. right? 99 rupees he spends. Nice. So many variations of this we have seen, right? So we'll continue this. We'll have more problems on this coming up. I'll see you again very soon. Thank you so much. Let me know how you found the session. What more do you want in Algebra, right? And any doubts, any things to ask, let me know. Thank you so much. Stay connected and see you in the next session. Thank you so much.